Today's 121 dual air brake equipped trucks are a new breed of vehicles that have made tremendous strides towards incorporating the safest and most effective braking system to date. Although these new systems are technologically advanced, one misconception commonly held is that these systems are too complex and problems are very difficult to troubleshoot and repair. As we will see shortly, this air brake system is actually easier to repair, since problems can be more readily narrowed down to a specific part of the system. To help you understand how this braking system works, Bendix has produced a similar audio-visual film entitled Air Brake Systems Part 2. It might be helpful to also review this film, as it explains how the dual system and its various components function. As a supplement to this, your Bendix distributor has available a large full-color chart for your use that illustrates the dual system and its components. These two AV programs, along with the wall chart, will help prepare you for troubleshooting problems that you may encounter in the 121 dual braking system. What we will be concerned with in this program is how to tackle a complete 121 pneumatic system checkout step by step. Although we will take a close look at the 121 air system, we will not get into anti-lock electrical systems, as these systems will vary and the respective manufacturer should be consulted when a problem is confronted. The following tests that will be made when checking the air system can all be traced to two main objectives. Number one, we want to determine that each component functions the way it should. For example, when air is released from the front service reservoir, the rear service reservoir should maintain pressure. And number two, we want to determine that leakage in the total pneumatic system and all of its components is within the allowable limits. To accomplish these two objectives, we have broken our tests down into 5 major areas. Our first series of tests will check pressure buildup. These tests will also include checking the low-pressure warning system and governor cutout pressures. The second series of tests will check for leakage on the reservoir air supply side of the system. The third series of tests will check for leakage on the service delivery side of the system. Fourth, we will test the manual emergency system, and in our last series of tests, we will check the automatic emergency system. To provide a handy means for keeping track of these test results when checking a system, Bendix has made available this 121 brake system test and checklist. We will work through this list step by step and cover the various test procedures, as well as some important checks that can be made to help locate a specific problem. As we go through our investigation of this typical 121 tractor and trailer air brake system, we will occasionally refer to a color-coded schematic of this system to help you get a better idea of how the various components fit into the total picture. Well, without saying any more, let's begin. After blocking all the vehicle's wheels securely, our first step in approaching this air system is to visually examine all tubing for any obvious signs of damage, such as kinks or bends that could restrict airflow. All hoses should also be inspected to reveal any possible signs of wear, drying out, or overheating. The suspension of all tubing and hoses should also be examined to make sure that these components are properly supported. A hose that is allowed to rub against a frame component will soon begin to abrade, and failure may result. On the same note, a piece of tubing that is allowed to vibrate excessively may lead to a fracture and, in turn, failure. Once these preliminary checks have been completed, we are ready to begin our first series of tests. Here we will be checking governor cutout pressures, the low-pressure warning system, and air compressor buildup time. We should begin by completely draining air pressure from all reservoirs. If the vehicle is equipped with a Bendix air dryer, there should be little or no water in the reservoirs. After the reservoirs have been drained and resealed, the engine should be started. A couple of things should happen as the ignition or kill switch is turned on. First, the low-pressure warning light and buzzer, if so equipped, should come on. And second, on some vehicles, the anti-lock and failure warning light will come on. Consult the appropriate operator's or service manual to be sure of the correct reaction, for not all anti-lock systems are alike. Watch the dash gauge or gauges as air pressure builds up, and note the governor cutout pressure on the checklist. Compare this value with the specified pressure given in the vehicle manual. For most compressors, this specification will fall between 100 and 130 psi. If the governor is not unloading the compressor when it should, then the problem should be corrected before continuing. Now, with the engine idling, apply and release the brakes to bring the service air pressure down. Note the specific pressure where the low pressure warning light comes on and mark it down on the checklist. If the light comes on below 60 psi, as indicated by the dash gauge, the low pressure warning switch is faulty and must be replaced. If the light comes on between 60 psi and 80 psi, then the warning circuit is functioning properly. After low pressure warning occurs, increase the engine speed to full governed RPM and record the time required by the compressor to increase pressure from 85 psi to 100 psi. Generally, this should not exceed more than 40 seconds. If build-up time is considerably greater than this, then a problem exists and it should be looked into further. As noted in checklist number 1, some possible causes could be a slipping compressor belt, clogged air strainer, restricted inlet line, or internal leakage within the compressor. Up to this point, we have tested and verified that the compressor, governor, and low air warning system are functioning properly. We are now ready to test the supply side of the system. Here, we will be checking for supply system air leakage. Let's first graphically pinpoint what part of the total system we're going to examine. On this schematic, the different colors denote specific segments of the air brake system. The red color represents the front tractor service brake circuit, and the green color represents the trailer and rear tractor service brake circuit. The blue color represents the compressor and supply reservoir, while the orange color represents the emergency braking circuit. The lines that have been highlighted here represent the portion of this entire pneumatic system that we will be looking at in these tests. This is the entire air supply system. As can be seen, since the supply system feeds all circuits, we will be examining a part of each circuit. The other part of the circuit, which is the delivery side, will be examined a bit later in the program. Our first order of business is to identify all reservoirs on the vehicle. If a trailer is connected, these reservoirs should also be identified. A tractor or truck will generally have at least 3 reservoirs, 1 supply reservoir and 1 service reservoir for each circuit. A trailer will generally have at least 2 reservoirs, 1 for the service system and 1 for the spring brake system. Remember that other reservoirs may be present to supply air-operated accessories, such as lift gates. These should also be identified and marked. To identify the reservoirs, each one must be drained individually, and the reaction of the dash gauges should be noted. For example, when the front axle reservoir is drained, the dash gauge for that system will show a pressure loss, while the rear axle gauge will not. On the same hand, if the supply reservoir is drained, both gauges will remain the same. Care should be taken when attempting to identify the supply reservoir because an accessory reservoir will reveal the same symptoms when observed. Therefore, it is sometimes necessary to trace the pneumatic piping to determine if a supply reservoir or accessory reservoir has been located. This procedure should also be followed for identifying trailer reservoirs. To begin testing for supply system leakage, build system pressure to governor cutout. Release the parking brakes and stop the engine. Allow the system pressure to stabilize for a minute or so and begin timing for 2 minutes while watching the dash gauges for a pressure drop. Then note the 2-minute pressure drop for the front and rear service reservoirs on the test list and compare this value with the allowable limit specified for the vehicle type involved. These specifications are illustrated in the checklist for test number 2. Because you're dealing with a 121 dual air brake system, any excessive leakage that is observed can easily be isolated to either the front or rear axle service supply circuit. By observing the dash gauge, we can quickly see which circuit is faulty. In turn, valve, line, and fitting leakage tests will only have to be made on those components in that part of the system. If leakage is excessive, but the dash gauge readings remain relatively the same, then the problem is in either the parking system, the tractor protection system, or trailer if a tractor and trailer rig is involved. On a straight truck or bus, only the parking system would need to be checked.